Just wait for 2 more minutes.
Yeah.
Okay. Good evening and good morning to everyone. We have more than 40 people joined. We are, I think, good to start. So, welcome to 126th meeting of RIT Alumni Advisory Hub. Thank you very much for taking your time and being a part of this session today. So, today's agenda is we'll start with opening remarks, talk a little bit about Raha initiatives for the people who are joining first time. Today's topic of discussion is semiconductor revolution, forging the next generation of chip makers in India. And we have a speaker present with us today, Mr. Varad Lad. He's joining us from USA. Thank you very much. And then we will end with a small discussion of question and answer and concluding remarks. So before we start with the topic, who do not know about RA, RIT Alumni Advisory Hub is an independent organization created by alumni of Rajaram Bapu Institute of Technology, Islampur. We started this initiative in year 2020 to create an active network of alumni, students, and the institute. So Raha activities also support RIT strategic goals and strengthen the ties between alumni, students, institute, and the community. So we are coming together since last 4 years with one vision to build a globally active alumni network to run sustainable and high impact programs in a collaborative environment between alumni students and the RIT Institute. So we work with mission of connecting three pillars: alumni to institution, alumni to students, and alumni to alumni. In the first pillar, we try to help the institute in curriculum formation, then supporting with some guest lectures in the RIT from industry expert, and to seek for best practices from global universities. For student, we have been organizing different sessions like today, the webinars, and also help with job readiness and higher studies, including overseas studies. Alumni to alumni, which was the core concept of this organization, was to provide business opportunities among the RIT alumni, support new entrepreneurs, and then give business support through alumni expertise. Till today, we have completed 125 weekly progress meetings, which happens on every Saturday, 9:30 p.m. to 10:30 p.m. IST. We have completed 30 webinars on various type of discussion topics. And to organize this, the core committee have been meeting continuously for review meetings, for preparation meetings, and that count goes more than like 230. So, without waiting further, I would like to introduce to today's speaker and the today's topic. Our topic is again semiconductor revolution, forging the next generation of chip makers in India. Our speaker today is Mr. Varat Pramod Lad. I will just do a little bit background about his education and the career. He completed his Bachelor's of Technology in Mechanical Engineering from Sanjay Gauda University, Kolhapur, and then he went for further overseas studies to Arizona State University, where he did Masters of Science in Mechanical and Aerospace Engineering, and his specialization was in semiconductor field. He has a broad experience in the semiconductor and research and development field. He's ex-NASA project specialist. Then he worked as a ex-R&D for UAV at RAN Innovation, and currently is working at one of the biggest semiconductor companies known as Taiwan Semiconductor Manufacturing Companies (TSMC) in the Fab Development and Management Division. Today we are going to touch a little bit of everything for semiconductor industry. We'll start with a little bit about semiconductors, what is the technology and the market trends, a little bit overview of semiconductor manufacturing process, which starts from silicon wafers and how we see the chips. Then India's expanding role in the global semiconductor supply chain and how the key players like TSMC, Intel, Samsung, and then see like what is the India's upcoming venture with Vedanta Foxconn. And then after this, we'll see what career paths are available for today's engineers, which can be design engineers, process engineers, R&D roles, and management opportunities. So I would like to hand over this session to Mr. Varat. Varat, please share your screen and start the presentation. Thank you.
Hi, thank you so much, Manali, for this amazing introduction. Um, I'll start without any further ado. One moment.
Mirza sir, can you please start the recording of the session?
Let me know if you can see the screen. Uh, can you see the shared screen?
Yes.
Okay, perfect. So we'll start, right?
Okay. Okay.
Okay.
Recording is going on too. Thank you.
Okay, perfect. Okay, so hi. I know Manali introduced me, but let me do the formals first. I'm Varat. I just graduated from Arizona State University a few months ago. I completed my bachelor's in India from Sanjay Gauda University in mechanical engineering, and I did my master's like right after I graduated from bachelor's. So I came here in 2022 for mechanical and aerospace engineering, and from I think 23 summer, that's where I started my semiconductor research. uh, I had my first internship in semiconductor industry, and that's where I started getting interest in this industry. So I started doing like a lot of research projects, some personal projects too. I started looking for jobs and um, to get experience in semiconductor industry, because this is like the biggest in
Yes,
on hands-on practical industry for somebody to get their experience in. So I started this not like very long ago, my semiconductor experience, I think a year and a half ago. But from that, whatever I have learned, and I'm still learning, I do want to put that into work for our country. We'll discuss a lot of things in this seminar. This is not like too technical. I'm not diving into too technical terms, or I'm not going into like very deep into like how semiconductors are manufactured. But we'll talk about this initiative which I'm starting, and what I want to convey, uh, the message to Indian institutes, to people who influence the institute, people who are in touch with the education system. And we'll discuss some points which are neglected by our system, and why is it so important to focus on the semiconductor revolution, which is actually happening in India in next 10 years. So let's start. Um, okay, so who am I and why would you listen to me? So I'm currently working in TSMC. TSMC is number one semiconductor manufacturing company in the world. They hold almost 87% of semiconductor supply in the entire world. Rest is Samsung and Intel. I'm currently working there as a project engineer in fab development division. So my work really involves working around with troubleshooting the tools, basically developing the entire fab and develop like looking to develop the new fabs and things related to that. I did my master's in mechanical and aerospace, like I said, from Arizona State University. I did not actually choose to, I did not choose Arizona to, start my career in semiconductors, but I was still doing trial and errors for my career. I did not know what path I had to choose. So I came to Arizona State University, and that's how this journey actually started. I did my BTech in mechanical engineering from Sanjay Gauda University. So in my first semester, ASU has a lab of NASA, so they do provide like a lot of volunteering internship positions. So in my first semester, I did work with NASA as a project specialist. My work was involved in reviewing the project proposals for upcoming missions, and we had like 11 project proposals and we approved 7 of them. So we had to go through a lot of checklist and all the stuff to approve that project proposal, and there are a lot of stages after that too. So we had like 7 approvals for upcoming projects in like next weeks. I did that. Well, I was working as a R&D specialist in RAN innovation. I was working basically on the UAV machines, UAV which are used in military. They are unmanned aerial vehicle. Basically, they, if you know, like if you have gamed before, like Call of Duty or something, the UAVs are uh, basically planes which detects enemies, but they are like autonomous. They don't have anybody inside. So I was working on increasing the radio frequency of those UAVs, and to make thin film depositions with the chips used in those antennas for the radio frequencies. So I did that. Then since that, I think since my first internship, I've been doing research in semiconductor industry. I've been doing personal projects. I've been trying to figure out why is this industry so big and why does nobody know about this that much. And India has been looking into it from February 2024 this year, and why people should be and why students, especially the students who are in bachelors, should be aware of this industry. uh, Agenda of this seminar would be, we'll introduce what semiconductors are. We'll talk about why the semiconductors are the future of the world and even for the India. What's India's stand right now in the semiconductor field, and then what career paths and what opportunities would they have, the students, and how can the students in the universities, how can people who have the same ideas, how can the people who are like-minded to start this initiative in India can get involved in this. And at the end of the entire seminar, we'll have a Q&A. So before we start, uh, let's talk about this industry and what is like all this initiative and why I'm trying to do lectures with different universities. uh, Even my university at ASU, I'm trying to figure out how we can collaborate our university to like work along with Indian institutes. So the biggest issue, so this is like an open platform, okay? This is not a technical session or a lecture which I'm trying to give you. It's like an open platform, so feel free to open your mic, ask me questions. If you have any doubts, if you don't understand anything, please ask me. And this is like open mic session, so everybody can get involved. uh, First of all, the issue, I found out this like very long ago. while I was doing my bachelor's. Uh, Actually, like, I mean, think about your bachelor's too. When we were studying for our bachelor's, we had no idea what path we had to choose for our career. Most of us, especially in mechanical engineering, a lot of students just choose IT, or like there are a lot of companies hiring mechanical engineers. uh, Cognizant, Infosys, they hire like engineers, but for IT roles like data engineers or system engineers. The thing is, that's where I think uh, we are lacking as a education. Uh, I wouldn't say institute, but uh, students need to be aware of this industry. For me personally, I did not know what path I had to choose after I graduate. So I just started following people who were, choosing IT for their career right after graduating, applying to Infosys, applying to TCS, Cognizant. But I didn't know, or we, like all the group of us, we didn't know about semiconductor industry back then in India. There were few semiconductor companies or semiconductor packaging, or like uh, who works on like small scale designing of semiconductors. There were those companies. They would definitely hire somebody with mechanical experience, but we were not aware of that industry. So this platform that I'm starting, this initiative that I'm starting, is to make students in India aware about this industry and what's happening in India. Yesterday, I had a lecture at ASU too. I had a alumni network at ASU, and then during that lecture, I did present this initiative to a lot of people. I think there were like 80 or 90 people in a hall, and a lot of them, like Indians who own businesses, like multiple businesses in US, who has green cards, and who are in like tech sectors. So they are in contact with a lot of educational institute connections in India, so they actually address this issue very well. They also said like there are a lot of institutes that do not teach about semiconductors. If you really think about it, we only get taught about VLSI systems, we get taught about integrated circuits, but nobody taught us about semiconductors that much. I did talk to a lot of IIT professors as well. They said their education or their books doesn't include any semiconductor knowledge, especially semiconductor manufacturing. Manufacturing is the biggest part. Designing, packaging is available in India, but manufacturing, we are not taught about it. So the start would be educating students about this field and making them aware of this field, like what semiconductor manufacturing is. The next step would be getting institutes to collaborate with government incentives, which are actually available to form a lab or a research project in the universities. I do have few project ideas which we can execute, uh, and to start something of semiconductors from the colleges, so students can get involved. There are like a lot of formula SAE groups in universities. There are like a lot of research group, there are a lot of research labs as well. But I believe that we need to focus more on semiconductor manufacturing, as this would be like a revolution in next 10 years. We'll talk about what is like the current hold of semiconductor manufacturing in India. And so for students, I think like the students who were at my age, 20, 21, who were graduating from bachelor's, the only thing that mattered to get a job was money and how much salary I can get. I don't care about the job, I don't care about what I'm working on, but I'll just care about how much money I can make and leave peacefully. So we need to make sure that students know how much revenue or how much money this industry holds. I mean, if we really think about it, if we dive deep into like researching how much money this holds, this does surpass lot of industries, including IT. Uh, if you are familiar with the Nvidia's rise this few months, you know that Nvidia has surpassed Microsoft in their yearly revenue. They are doing trillions of dollars every year right now. and they have surpassed Microsoft. So this is the right time for students in India, in Indian institutes, to get involved in this industry, because this wave will come to India in next 10 years. And I think, or everybody thinks here, that we Indians need to be prepared, and the things which are like taught in US universities, we need to start that in India, with our government support and with all the professors around the world, all the universities, and uniting them all together. So we might have a possible funding from government, because I've been talking to some people about this initiative. But the first step would be, we should make students aware of this industry and make them interested about this. Let's dive into the basic technical knowledge of what semiconductors are. This session was especially made for students who were interested in career growth uh, from their bachelor's. So we'll start from this. We're not going too technical. So what are semiconductors? So basically, uh, let's say it's a wafer. It's a big chip. We'll say we call it wafer because it's round and like really thin, and this is made by sand. Okay, so something which comes out of earth, which is like a natural resource, won't even go like extinct. If we run out of sand, we'll just get it from another planet or with some form like alien technology. But jokes aside, this is a natural resource. Okay, so the chip comes from a sand, basically. Okay, so sand goes through a lot of processing, pre-processing, post-processing, purifying, and a lot of stuff, and then it it becomes so sand has like a lot of silicon particles. They catch that, they purify that, it goes through a lot of processes, and they form silicon ingots, and those ingots are like chopped like really fine into like 12 inches disc. Usually it's 12 inches by industry standard all over the world, but it can be smaller, it can be bigger too. But usually the chips we use are built on the 12 inches wafer. So it's 12 inches in diameter, and they are polished to like a mirror finish. It's not even close to a mirror, it's really clear. You see a lot of details of your face if you look into a wafer chip. uh, Before it goes to like all the machines, when it's like really fresh, there are like a lot of details you see about you that you didn't even notice. So it's like really clear surface and really smooth. So that's why like the semiconductors fab have clean rooms, because any particles, even an atom, like a small particle of like dust goes on that, there are like a lot of yield issues, and like companies lose a lot of money. So on that single chip, there are trillions of transistors in, like, let's assume it's uh, not 1 inch, it's like a 1 millimeter square of that chip. And in that square, there are like trillions of transistors, and those transistors are 25 atom wide transistors. If you think about an atom size, you cannot even imagine, I cannot even imagine. uh, Nobody can imagine an atom size. If we like close our eyes, we have to go microscopic, not even microscopic, we have to go really deep into it, really 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 micro. And then assume those atoms, and one transistor is here and the next transistor is 25 atoms apart. So these transistors are printed on atoms. So imagine what kind of machines they use to print those atoms, print those designs on atoms. Basically, we are printing things on like atoms, like really really down there. So isn't it like really surprising, like how can humans make a technology which is almost really science fiction? And if you think about it, I've only seen something like that in movies. I've seen it in personal too, like at TSMC. But humans back in like 1980s, 1990s, they have not even 1990s, 70s, and 60s. They have made machines which print things on like atom wide apart. and those things become like energized, and we use those things in like computers, rockets, coffee machines, fridge, mixers, lot of stuff. And this is made by a human. And the machines which are right now in US or in the world, the most advanced one are in Taiwan. But the machines that we have as a human race, we use the same principle that we used like 30, 40 years ago. So humans came up with this entire idea 20, 30 years ago, and we are still like using that with the same technology, but we still like we have a faster process, we have smaller designs. So the 25 wide apart transistor, this information is publicly available, but if you actually think about semiconductor industry, it's really confidential, so people do not disclose a lot of information. But I'm pretty sure the 25 atoms apart size has been reduced to like 10 to 15 right now, but the only publicly available information is 25 wide apart, because there are a lot of confidential stuff that companies don't discuss or disclose to the public. But the machines I was talking about, uh, they are like big machines basically. I mean, for like from a human's perspective, I've been working on those machines since 3 months. The first day I saw those machines, where I felt like I was not even on the same planet. Those machines are really big. If you stack three elephants all together, and like it's that wide from that part to this part, it's like, and in the height, it's, if you like stack three elephants all together, the height is like that much. So these machines are big, but their results, their products is like a small atoms and the prints on atoms. So the process for this is called as photolithography. It's a big name, but the name has its meaning in it. It's photolithography. So we know what lithography is, and it's photolithography means we are printing a design which we have in our system on something else, and we are like doing a lithography on it. But those designs are really big. I assumed 1 mm square chip, but it's not 1 mm. It's smaller than that. It's we measure it in nanometers, the size of the wafer and the chip. So it is printed in pattern, so it's equal pattern all over the surface. So if assumed 1 mm uh, area of that chip has trillions of transistors, and it's a 12-inch wide in diameter chip, there are a lot of 1 mm squares, and it's printed in patterns. So there are like trillions of trillions and trillions, lot of transistors on a single chip. And and these kind of chips, a big manufacturing company like TSMC, they produced almost 300K to around that chips a month. So they have like really good, you know uh, manufacturing yield of those patterns, because it needs like really precise work and attention to details and all the stuff. But they have really good yields too. So there are a lot of processes after like photolithography that the chip goes into, but we would not dive really deep into it because this will elongate the session. We'll talk about our initiative. But on the left side of the presentation, you see those, the colored lights you see, those are laser beams. So if you can see my mouse, yes, you can. There is the wafer chip right there, and let's say this is the source of those laser beams. Let's assume this is an EUV machine. We call this an EUV machine. So this machine is fed by a design. So a design team or an engineer who's owner of this machine will feed a design to this machine, and there is the wafer. And what this machine does basically is make the design so small that it's like at a size of an atom. So it goes through a lot of refraction, a lot of stuff. It goes through, even it goes through the fusion, because it's laser, and We call it EUV because they're making artificial UV lights. So it goes through a lot of fusion, and this designing transferred over the atoms of laser and the fusion particles, and it's printed on that wafer chip, which is like really really small. So I don't know how like a human came up with this kind of a technology, or how would he even think something like this was possible. But yeah, it's there. We still use the same principle they used 20, 30 years ago. When I started my research in this industry, it was really crazy. I mean, I did not believe anything I read. I thought this is all like crazy stuff. And I found it like really science fiction, kind of felt like I'm reading like a science fiction novel or something. But it is really there. I saw it, and it's crazy. And I think India should have something like this, because we are making a revolution in next 10 years. uh, so the chips which are made from the science fiction technology, we use it like in everyday applications, everyday appliances. uh, let's assume, what do you have in your hand, or like in front of your face right now, is the monitor, or the laptop, or you might have a phone. You're watching this on phone. This phone contains almost thousands of semiconductor chips. Like it's a small phone, but it contains like thousands of semiconductor chips. Not just the processor which processes information, but there are camera chips which are semiconductor. There are charging chips, chips for chargers, and there are a lot of chips: fingerprint scanner, face scanner, whatever. But every every component of that phone is made by a semiconductor chip. We have a fridge in your house. Imagine if this contains thousands of chips. Fridge contains a lot of chips. There is a mixer do contain a lot of chips. Even coffee machine, they contain a lot of chips. uh, Photography equipments like cameras, lights, even mics, they contain a lot of semiconductor chips. The cars we use, any car you drive, the image sensor in the car, the car play you use, or you connect your phone to your car, that does uses a lot of semiconductor chips. The rear view camera uses a lot of semiconductor chips. Everything in your car is made, like everything electronic. The sound you hear from the speaker, they do use a lot of semiconductor chips. And so it's like everyday applications. Everything you see around you which is electronics has semiconductor chips inside it. So by this basic definition, we know that this would not go extinct ever, and this is why semiconductor companies doesn't have layoffs that much, because their jobs won't go away ever. Even the AI is coming up, we need chips to make the AI work. So even we think about AI replacing job of like engineers, they really cannot replace anything about semiconductors, because without semiconductors like chips, there won't be any AI. All the AI we see, the OpenAI, even the NVIDIA is coming up with a lot of new AI chips, AMD as well. They manufacture all the chips from TSMC. So there is no stopping for this industry ever. Recently, if you have seen on news, LinkedIn, everywhere, Elon Musk uh, did something really crazy that nobody has ever done. Uh, he catched, so this equipment he calls this tower, he calls it chopsticks. So okay, I got a question. Hold on. Is it like printing optical encoders scales 1 micron? It's basically that, but it's lot more precise than, when I say printing, I'm just making it really easy for a lot of people to understand, because not everybody has uh, that technical knowledge. But it is just like printing. That's why it's called photolithography. uh, but it's not really like the prints we put, like the inks or anything. But the basic concept would be, let's assume this is a design and this is the wafer I want this design to be at, but this design is like in a big scale. but we are like reducing that design like to like really small scale and putting that design on an atom. So that, I mean, basic that concept would be printing, but there are a lot of stuff. There are fusions, the sand particles separates, and then there are a lot of like gaps, and then etching goes like the next process would be etching and all the stuff. But yes, I mean, in basic, so simple words, it is uh, printing. uh, how do I start working on? We'll talk about that later in this seminar. We'll talk about how you can get involved, and how we could start something in India as well. But yeah, I was talking about Elon Musk. So this equipment, he calls it chopsticks, and he catched his rocket with those chopsticks. So this is like really crazy experiment. He has done a lot of like reusable rockets. He landed all the rockets like again, and he reuses all those rockets. But this was something crazy, like nobody in the world has ever done it. Nobody has that power. Even Russia doesn't have this kind of a power. Even somebody other than SpaceX, because Elon Musk's company is SpaceX, the direct competitor is NASA doesn't even have this kind of a power. But this was a trial and error experiment, and it was successful. And this, trust me, this used like lots and lots of semiconductor chips. Even this feels like a construction construction of some, rods and a structure. But this is not just a structure. This has a lot of semiconductor chips in it. This is all made with its own brain. It has its own brain, the AI and all the stuff, people operating on that AI. And the rocket has like a lot more semiconductor chips than we actually think. So semiconductors are actually everywhere. There's some like sci-fi technology that we use every day in our life without even thinking about it. uh, what skill sets do I need to acquire to work in a semiconductor? We'll talk about that in like last two slides. I'll go through like everything. I'll address all these questions, and let's move. Okay, so this industry, I don't want to be too technical because I don't want to bore a lot of people. And somebody, it's, I think in India it's like really late, and some places is really early. So uh so this industry, it's based on Moore's law. So this law has been alive since like way back. I think say when we all, some of our, like some of us were not even born, and some of us were like just born, some of us were born and they were in this world for a few years. But yeah, it formed like really back in 1970s, and the person who came up with this law is still right. Okay, like he was right then. Like he came up with a law that concludes that this industry, like semiconductor industry, where nobody knew about semiconductors, he said that the number of transistors on a chip would double approximately like in next 2 years. So let's assume, okay, this assumption numbers, these are not real numbers. Let's say we have 100 transistors on a chip today, okay, right now in 2024. So in next 2 years, those number of chips would be 200 on a same scale of a wafer. So for that, we need to reduce the design way more, like at least a half, like half, so we could fit double transistors on those chips, on the same chips. Okay, so this law has been true since 1970s, and every 2 year there are modifications in design, there are modifications in tool, there are developments in tool, and the design gets smaller every 2 years, and the number of transistors are increased. Like I said, the 25 wide apart atom size, that was just publicly available information. I don't know when was this published, but if you think about it, if every 2 years the number of transistors are increasing, then actually it wouldn't be even 25 atom support right now. It would be like really smaller. I don't know. It might be 7 or 6 atoms wide apart, because to fit a lot of transistors and then double it next 2 years, we need to reduce the either like the size of a design and reduce the space between those prints, or we need to increase the wafer size, like more than 12 inches. But nobody does more than 12 inches, because the yield, like there were like a lot of trial and error issues back in the industry. But the 12 inches has been set by the industry, so they reduce the design and they reduce the size of the atom too, the size between the atoms of the prints. So Moore laws says that. So if we really think about it, this applies all over the world, and this applies for our country too. Uh, uh, in India, we started like really back, but we didn't have manufacturing fabs in India. The biggest manufacturing fab, which country manufactures most? I mean, yes, that's what I'm talking about. So Taiwan is the hub for semiconductors since the beginning. Since the beginning. So when TSMC started, they did not have that much hold over the world, but they had hold over their own country. So for semiconductor supply, but right now, everything in the world, almost 60 to 90% of semiconductors are manufactured by TSMC. Taiwan holds most of the semiconductor market. Taiwan holds most of the semiconductor manufacturing market. Taiwan holds most of the semiconductor packaging market. Lot of fabless companies, which do like designs of semiconductors. Uh, they send their design to TSMC, so we could say even they hold the design market as well. So everything is held by TSMC uh, at this point. And there are competitors, but they do not compete directly with TSMC, because TSMC manufactured the chips. Samsung is there, Intel is there, but they are having yield issues recently. So that's the thing. But
Just
so
sorry to
yeah,
interrupt,
no,
but
no
just
problem.
wanted to remind you of the time. We have like 10 to 15
Oh yeah,
minutes
yeah,
left, and I think
sure, sure, sure.
students would like to know more about how can they start working in the field and what are the opportunities.
Yeah, yeah, of course. I'll just go through one more point on this page, and then we'll dive directly to Q&A.
Thanks.
Yeah. So right now, this industry hold a lot of value. It hit 53.5 billion in 2023 and exceeded 67 billion in 2024 because of AI. So AI revolution has already started from last year, and India has to be in this race. Dive into it. We have started a lot of projects in India too. So probably in next 10 years, we'll have like the foundation of entire semiconductor manufacturing industry. Next, these are the global leaders. I won't talk about that much, but like I said, everything starts with TSMC. Yeah, 62% of market, and there are a lot of the difference. I'll talk about like maybe in next session. But yeah, in India, we have investment of $38 billion in 2023, and we might get like in next, even if I say 2030, I'll say from this point on today, and the next 10 years will have more than $109 billion investment in the semiconductor industry. So it is like really obvious that India is making investment in this project. But the thing is, the students lack knowledge, or students lack the information they need to have in order to pursue career in semiconductor field. There are a lot of students who are like really aware of the news and really aware of the industry, like really smart and genius students. They know about this stuff, but we need to make sure that we form engineers who can hold the future of semiconductor industry, especially in manufacturing side. We have a lot of design, we have a lot of packaging, but we need a lot of manufacturing projects too. And like I said, like Tata is partnering with PSMC, which is Power Chip Semiconductor Manufacturing Company, which is also of Taiwan. So they're partnering with that for 12-inch fab in India. This is the first manufacturing fab we are starting, and it's going to have 20,000 new jobs every year. because fab require a lot of people, fab require a lot of landscape, even infrastructure, and the graph just keeps going up, so there is no stopping. And yeah, this is the most important thing. Okay, I'll just cover this one. uh, the current node in India is 28 nanometers and older, so bigger than that, so 28, 30, 54, 60, and all that. But in US it's 7 nanometer, and in Taiwan it's 1 to 2 nanometers. Okay, so people don't really talk about this, but these countries are like 10 years ahead of all those things. And the only issue I see with all this is I was not aware of this industry. If I would have been researching about this industry from the beginning of my bachelor's, I would have started career in semiconductor like way back. So the initiative talks about making universities collaborate with government and forming a lab or a research project that involves a lot of students working on like a same goal to push India into this industry a lot. By India I mean students who are studying in India or students who are seeking jobs in India, and we need to push them to uh, be in this field more. So we'll open up the platform for Q&As. Yeah, let's go. Okay, okay. What? Okay, hold on. Chinmay says,
Yeah.
what skill sets do I need to acquire work in semiconductor field? Okay, so these are the roles you can be in a semiconductor field. You can always be in research and development where you're working on like new technologies, new researches, integrated circuit designs, process engineers. So you just, if you look to the positions, uh, just do one thing. Okay, today you just go through any positions in a semiconductor industry in India, not like abroad or anywhere. You'll see like a lot of basic stuff. It's not that complicated because they expect students to be working on these things. So I would say to be in semiconductor manufacturing field, you need to have semiconductor manufacturing knowledge. You need to know like what this concept is, what this industry do, what is semiconductor manufacturing, and how semiconductors are manufactured. I won't say like you need like really hardcore skills. Like in IT, if you want to be a data analyst, you need to know a lot of data engineering, a lot of codes. If you want to be a software developer, you need to know like how to build a website or a software and application. But if you really think about it from like my perspective, I don't think you need hardcore skills, but you need personal projects, hands-on experience on those personal projects. Manufacturing experience from those personal projects that you do, but most importantly a knowledge about the industry, knowledge about the company you're applying for, and knowledge about you know overall semiconductor manufacturing. Or if you want to be in design, then the knowledge about how designs are made, how we use the design, how we create the design. So start from like gaining basic knowledge and understanding the concept of like basic things. And once you do that, reach out to me. I think Nali has posted the LinkedIn link, something we can talk about, your career opportunities in future.
Yeah. Mr. Nitin, can you please mute yourself? We have a hand raised by Shabana Desai.
Yeah,
Shabana, if you have a question, can you please go ahead and ask?
did you put it in the chat?
Okay, I think she left. Arya, do you want to just unmute your mic and ask the question if you're there?
So my question is, will there be any shortage in future regarding semiconductor?
Yeah, so will there be shortage in future for semiconductors? How does the industry ensure stable supply to meet this growing demand? See, there won't be a shortage of semiconductor because the resources are natural. Usually the shortage happen in an industry where the resources are limited, or probably because of the revenue system, or probably because of the budget cut down. From the beginning of the semiconductor field, there was a shortage just once in the entire lifetime. That was because of COVID in 2020, and that affected a lot of automobile industry because the chips, like those industry need chip as soon as possible, like immediately. But other industries like phones, laptops, they have their chip supply for like next 3 to 4 generations, so they pre-book the chips from industry. So I would say there is no shortage for semiconductor industry. But if we the industry do require a lot of workforce and manpower. If we are talking about semiconductor manufacturing, I don't think we'll ever get extent of humans to work on a semiconductor fab. So overall, I don't think there would be any shortage in future. But the second question, how does industry ensures a stable supply to meet this growing demand? So I wouldn't go like too confidential into this topic, but I would say these companies do not think about tomorrow. They think about the day in next 10 years. Okay, so their entire supply is uh, made for next 10 to 15 years. And right now, if a company is working on any chip or any design, they're probably working on like sixth generation from today. Something they need to release in 2030 or 2031. So they already have a future plan stable. They already have their basis stable. At least the countries who are leading this industry, like Taiwan, they are way ahead of us, even US. That's why US gave them, the land to form something, so US could lead into the semiconductor industry, and that's what is happening right now. I think India also need to uh, understand. They do understand this, but we need to make students aware about this industry a lot. Next question.
Shardul, Shardul Devrukkar.
Good evening, sir. First of all,
Hi. Good morning.
very early. And
Yeah.
yeah, sir, I want to just ask the question. Why nowadays the semiconductor has become a daily part of life and also affecting our daily lives. So the shortage means we can't expect, but
Yeah.
due to means now international relations also it has affected in middle. You you are aware.
Mm,
Because the senator or the MP from US, the Nancy Pelosi, has visited over there.
mm.
So and also, so by war it can't affect, no? Means
No. So see, if a countries like superpower is based on an industry, or I don't think any country's superpower is based on like a technical industry right now. But some countries do have their eyes on other countries who are like really powerful in these kind of things. Let's say the thing you said, it is similar to the China and Taiwan issue, because China is trying to take over Taiwan because of the thing they lead um, in the world, because they have Taiwan, even if it's a small, island kind of a country, but they do hold a lot of control over the world for semiconductor supply. One of the main reason for them to be in US was to escalate this situation, because US do support Taiwan a lot. China is still threatening for that, so it's like it's a similar issue. But regardless of any geopolitical things, I don't think there would be um, any conflicts because of war, or like because of somebody else has been elected as a president, or because of uh, the rules which were way back before, and they cannot like hold those rules granted. There won't be anything like that, at least. But I don't think at our our point, our perspective, we should think about all those stuff. We should just think about how we can bring our country forward and bring our knowledge into this industry, and how we can like make an impact in this industry with India.
Exactly, exactly.
Yeah,
Because
yeah,
now we are entering in the era of fourth industrial revolution.
correct, correct. Yes, you're right.
Now we have first
And
of
this
all,
is like the biggest part of it,
yeah,
semiconductors. Yeah,
and that only.
no
And
problem.
Next
No.
question by Raj Kumar Patil.
so sorry to disturb, but I
Hello.
have two, three questions more.
Okay, okay, go
Hello.
Yeah,
ahead.
no worries.
What is the lifespan for the semiconductor and rather it fails?
Yeah. Okay. So there is no lifespan if there isn't any physical, damage. Semiconductors get damaged because of any while in processing, they do get like some failures because of, if the clean room is not really clean, if they have dust particles on wafers or chips, if they have any foreign particles on the chips. So that's why companies like Samsung, the S company, and the I company, they have yield issues. So by yield issues, I mean, let's say, assumption again, a wafer has 50 chips on it, and out of those 50 chips, only 20 are working. So that's ridiculous. I mean, that's like really low yield. So yield failures means that. So let's assume a company who is manufacturing chip, they have 50 chips on a wafer, and they are like 48 of them are working. That's a excellent, that's excellent results for yield. So companies like failing because of yield, they do go through the thing you questioned about. They do get failures, but when they are in like appliances or application, other than physical damage or other than any natural things, like assume we put our phone in the water and it gets damaged, that's kind of, that's an issue. But on a bigger scale, uh, that the issues involved during manufacturing, they are real deal. That's why we need to focus on yield issues. One of my project is working on that too. I hope that answers your question.
Sorry for that, Shardul. Just that, can you bundle up your questions together and ask? Like, we have 5 minutes left and few more questions to address.
Yeah.
Please go ahead. Shardul, can you unmute?
Sorry to interrupt, but other than silicon, we can use metalloids or the
Yeah,
like,
yeah, amazing question. Okay, so right now in US, even I was working on that too. In, I think, 6 months ago, we are working on coming up with a material which is other than silicon. But the major part we went through, like in R&D, the yields you get from silicon you cannot get from anywhere. And why would, so this question arises again, why would we think about an artificial material instead of getting something from nature, which is like a sand, and it doesn't have like an ending period. Like sand doesn't have, if we run out of sand from earth, we'll get it from some other country or something, but or other planet or something. But uh yes, there are a lot of research in this, the questions you talked about, and I do need these kind of brains for this initiative. Please, Shadow, please reach out to me, we can discuss more about this, and how we can like
I'm
start a research on that all together.
I've connected with you.
Of course, perfect. All right,
Thank you.
Uh,
no
I
problem.
want to take a one question from chat by Prathamesh Jadhav. He's
Yeah,
asking about what role can computer science engineer have in semiconductor industry, and do they have any future in this sector?
yes, amazing questions. Okay, that's the most controversial question, because when I talk about semiconductor industry, A lot of people think about just mechanical, electronics, electrical, that's it. But this industry does conclude a lot of other fields. They include nuclear as well, which is like really rare. They include nuclear engineering, they include civil engineering, they include construction management, they include computer science and computer engineering as well. And how computer science and computer engineers, they do work a lot with data. Basically they work with data engineering. um, I'll explain one scenario in our company. We have intelligent manufacturing team. Okay, so we call it intelligent manufacturing team because it's autonomous. This manufacturing is handled through computers all day, 24/7, all day long. So you need to work with a lot of data sets, a lot of data engineering, data analysis, a lot of predictions, a lot of statistics, a lot of mathematics. So we need a person who has knowledge in that. So technically, computer science, computer engineers, they do have strong mathematical skill sets. They do have strong data analysis skill sets. They do work a lot with codes and stuff. So we need people like them to be working in this division. So yes, there is a future for computer science in semiconductor industry, and there is future for anybody else working in any other different field in this industry.
Yeah. Next question is by Vaishnav. Where can we do a genuine internship in VSLI or semiconductor in India? Do you have any recommendations?
Yeah, of course. So um hold on. Okay. Yeah, so this is what I have listed. uh, you do need to look into Tata and the PSMC partnership right now, because it has started right now. They do need a lot of engineers. Try to connect people over LinkedIn instead of just applying through system is messed up. That's what I'm saying. In the entire world, the system is messed up. Even if you apply for thousands of jobs, you'll just get like few calls. I don't think in India people even like really aware about connections and networking. Because like in US, that's where the entire industry is based off. People who know people, they'll hire people. Okay, so if I know you and in person, and you say like I need to work in the semiconductor industry as an intern, I'll just hire you. So that's how it works. So networking is the biggest part of getting any full-time job or getting internship or anything. But yes, there are a lot of companies. Vedanta focusing on, you look into that too. Even if you like do a simple search, it doesn't have to be really complicated. Do a simple search, go on Google, semiconductor industry full-time positions or semiconductor industry intern positions. You'll get a lot of Google job recommendation. You'll get a lot of Indeed job recommendation. You'll get a lot of LinkedIn job recommendation. What I want you to do is connect the people who are responsible for this position. Connect with higher ups. Send them a message. If you see a startup in India with the semiconductor title in it, or maybe a startup who's working on like related stuff. There is a startup who's working on semiconductor packaging right now. You'll get their phone number on their info page or support page or a LinkedIn about section. Call them. And tell them that this is my experience. I'm working in on this project right now. I'm gaining my experience. I'm studying in this university or this institute, and I want to have an practical and industry experience. I do like your company. I do like what initiative you have, the goals you have, and I want to carry that. Do you have any open intern positions or full-time positions that I could apply for? And I'm available to interview. And this is like, you skip a lot of steps from putting your resume, then waiting for that result, probably get a rejection because of AI, and following up on that, applying to another position. Skip a lot of steps when you call like a company, or HR picks up or a manager picks up. Nobody's too busy to pick up the call. So you don't have anything to lose. Try to look into any semiconductor related field. Just gain your experience from internship, and then tackle all those big shot companies after you gain your experience in internship.
Yeah, I will just take this opportunity to emphasize that LinkedIn is a very powerful tool if used in a
Right.
skillful way, and it
Yeah.
can open multiple doors. I'm aware that we are on the time, but there are a few more questions. So, with everyone's permission, if we can please extend the session by 10 to 15 minutes. Uh, I have Diksha Suryamshi. Diksha, do you want to go ahead and ask the question? She has actually posted her question in the chat too. It's about opportunities for robotics and automation engineers and what should
Uh,
they focus on.
yes, perfect. Amazing question. So this is another field, okay? Robotics and automation engineers. So you probably get into semiconductor manufacturing because these fabs, they have a lot of robots around the entire fab. Trust me, I'm not lying. This is based on like real life story because first time I was in the fab, there were robots flying over my head. It's not like actually flying, but they have like rail rods all over the fab, and they're like going at a speed of 40 miles per hour. Like every robot, it's going at a speed of 40 miles per hour, and they're like 10 robots in a line. Do not make any mistakes. They do not do any errors. They're like there. So we call them AHMS, which is uh, air handling material system or something. Uh, Probably that. But yeah, and those things do need a lot of automations, a lot of robotics, and a lot of coding as well. So you might have opportunities in that. Like I said, semiconductor manufacturing companies, like any, let's say Intel, Samsung, TSMC, and then uh, any startup who's trying to do like manufacturing, you'll probably get into that kind of field. And there are a lot of machines that do need require robotics and automation. A lot of machines which have automated the manufacturing processes. So yes, there are opportunities uh, in the semiconductor field for you too.
Yeah. I'm keeping a question for the last in the chat. Before that, Mr. Rajkumar, if you want to go ahead and ask the question. Rajkumar Patil.
I think we should just take from the chat, right?
Yeah. Uh, I think this was a good question to end on that note. And
Yeah,
I speak for both Prashansa and Shraddha. They are both asking about students who are interested in this field and need like a starting point. Where should they
right.
start? And Shraddha is also talking about a roadmap for entering and advancing in this field. So I think
Amazing.
that's a good question to end the today's session.
Yes, amazing. So your answer would be reach out to me because I'm trying to figure out, like, to make a team who is actually interested in this field and who actually do want to like make an impact in this field. This is like really new, at least in India, not in US, but it is at that point where you can make an impact. Any individual can make an impact. If we think about, let's think about an aerospace industry. The only way you could make an impact is being in that industry for 20 to 30 years, being a scientist, doing some research, making some things like catching rockets with chopsticks. This is how you can make an impact in that industry. But semiconductors, anybody can make an impact. Don't think of yourself like you're somebody who cannot make a change or bring a change to a field like people hire in this field. But this is like really new. People are actually considering opportunities to work along, and the only thing is to be united and working on a same goal, to bring something forth in India. Please reach out to me. I do have lots of ideas. I will give you a roadmap to start a career and advancing in this field. Reach out to me with your name and just tell me that we talked on Raha platform, and we'll move forward from that, instead of uh, taking more time in this scenario seminar. And I will definitely give you a roadmap, and I'll give you, the structure which you could follow to, form your personal projects, do your resume good, fill your resume good. Every experience does, even if it's project experience, that does count as a experience. So we'll talk about that too, and yeah, we'll take it forward from that.
Thank you very much, Varat.
Yes.
For the people who are asking about how can we connect, I just again posted a LinkedIn link for Varat's profile. You can reach out to him on LinkedIn messaging, send your connection request. You can always reach out to one of us from Raha Task Force, and we can help you to connect with him. You have your own, our own Mirza sir in the RIT Institute, who can help you to connect not only Varat but all the other guests we have had on this platform. Uh, so, on this note, I think we are ending today's session. I would like to thank again Mr. Varat Lad for his time and guiding us students uh, about this new field. And I would take a moment to appreciate Raz's efforts on this uh, way that we have been always trying to students let know about the new career fields. How can they go to different fields after completing the engineering and not only follow the traditional way? For the students who are willing to study abroad and who are already studying abroad or trying to get internship and jobs, we have good news for you. Uh, who have been connected with Raha from like last 2 years, they already know that we have conducted a successful session on study abroad, life in Canada, to help the students for overseas studies. We are coming with a similar session for all, not only USA and Canada, but all the other countries. We will try to address everything starting from how to look for the universities, how should you apply for the universities, which fields are good for studying abroad, then your personal issues like trying to find the accommodation, trying to find the healthy way of like keeping your diet when you're abroad, and then how can you reach out to people for internships, jobs. So we will just trying to cover everything. The session details will be shared soon on all the Raha platforms. Stay connected on the LinkedIn groups, stay connected on our WhatsApp groups. I also shared a WhatsApp group for overseas communities. If you're already abroad and need help or just want to stay connected with your people, please join that group too. We will check with today's speaker about today's presentation, if you can share that. And if yes, we will try to share that in our groups. Uh, so on this note, thank you very much for everyone for taking your time so early in the morning or so late in the night. Have a good night and have a good day. Thank you.
Yeah, one more thing I want to mention. I really want to, appreciate the opportunity for giving me a platform to present this initiative. And I'm really grateful for you, Manali, as well, Raha platform, and at least letting me talk, and people listening to me. It was nice talking to all of you. I liked all of your questions. Please reach out with, all the questions. Reach out to Manali if that's your closest point of contact, and she'll convey your message to me. But don't be afraid to, ask questions, because everybody's young here. Nobody's like a professional higher ups or anything. Nobody's gonna judge you. I'm just like you. I'm your friend. Call me Varad and everything. Don't call me sir or anything. But be really transparent about what you want to do. If we, reduce or delete that barrier between us that I had with my professors back in my bachelor's, we could, form something really great and really good in India. And there shouldn't be any barrier with all those questions. Please reach out to me. Anything, if you don't even have any idea about what I have talked right now, reach out to me. I'll explain you like really well, one on one. And thank you so much for this opportunity. Thank you.
Thank you again.
No problem.
Thank you. Good night.